Hi everyone, notes 5.3 are on double angle formulas. So we are going to figure out how to derive our double angle formulas from our compound angle formulas. So if you look on your paper in front of you, there's a reminder for the compound angle formula for sine, cosine, and tangent. So we're going to use the compound angle formulas to derive our double angle formulas. So if you look right here, we know that sine of x plus y is equal to sine of x times cosine of y plus cosine of x times sine of y. Now, if I want a double angle, it means that I want 2 times theta as opposed to just theta. So right here, I'm going to replace x and y with both of those with theta, which is totally allowed. So I can say that sine of theta plus theta is going to equal sine of theta cosine theta plus cosine theta sine of theta. And if you notice here, theta plus theta means 2 theta. So I get sine of 2 theta is equal to, and here if we've got sine theta cosine theta, and here we have cosine theta sine theta, they're the exact same thing. So we can just say it's simply 2 sine theta cosine theta. And we just derived a formula for our double angle for sine. Okay? All right, now let's do the same thing for cosine. So for cosine, I'm going to replace x with theta and y with theta. Okay, so here I'm going to say cosine of theta plus theta is going to equal cosine theta cosine of theta. Again, instead of cosine x, cosine y, we're going to say cosine theta minus sine theta here, and then sine theta. So what we're going to do here is we're going to say cosine 2 theta is going to equal cosine theta times cosine theta is cosine squared theta, and sine theta times sine theta is sine squared theta. So we've derived our formula for cosine of theta, okay? But there are other formats for cosine of 2 theta that we can write here that will also work. So we're going to use our Pythagorean identity to help us derive other versions of this formula. So let's go ahead and do that. So remember, we know that sine squared theta plus cosine squared theta is equal to 1. Okay, so if I were to rearrange this right here, I can say that cosine squared theta is equal to 1 minus sine squared theta. Okay, so here what I could do, instead of saying cosine of 2 theta is equal to cosine squared theta minus sine squared theta, I can replace the cosine squared theta with 1 minus sine squared theta. Okay, so that's this piece right here, and then I will copy down the minus sine squared theta right here. Okay, and then when I put those together, I end up getting 1 minus, I've got 2 sine squared thetas. So this becomes 1 minus 2 sine squared theta, and that's what cosine of 2 theta is. So here's the second equation that we can use for cosine of 2 theta. Okay? We have another equation that we can also use for cosine of 2 theta, and that's if we rearrange this Pythagorean identity and we isolate the sine instead. So I could say sine squared theta is equal to 1 minus cosine squared theta. Okay, so right here I'm going to replace the sine squared theta with 1 minus cosine squared theta. So here I can say cosine of 2 theta is equal to, I'm going to copy down this cosine squared theta, and then I'm going to write minus, but I have to put this in brackets because it's minus this whole thing, 1 minus cosine squared theta. Okay, so that means that cosine of 2 theta is equal to cosine squared theta minus 1 plus cosine squared theta. So then when I put those guys together, this cosine squared and this cosine squared, I end up getting 2 cosine squared. So it's also another equation that we can use for cosine of 2 theta is 2 cosine squared theta minus 1. Okay? All right, so now let's do our last one right here, and we're going to do tangent. And instead of x and y, we're going to replace x and y both with theta. So I'm going to say tangent of theta plus theta is going to equal tan of theta right here instead of tangent of x. Instead of tangent of y, I'm going to write tangent of theta all over 1 minus, instead of tangent of x, I'm going to use tangent of theta again. And instead of tangent of y, I'm going to use tangent of theta again. So tangent of theta plus theta is just tan of 2 theta. And then tan of theta plus tan of theta is 2 tan of theta all over 1 minus, and then right here, tan of theta times tan of theta is tan squared theta. So this is my double angle formula for tangent. Okay, so now that we've derived all of these formulas, let's just summarize this. And then once we summarize it, we're going to use this and apply it to solving some questions here. Okay, so our first double angle formula is sine of 2 theta, and we figured out that it's 2 sine of theta cosine theta. So that's what we'll write down here. Okay, the second one we have is cosine of 2 theta, and we have 1, 2, sorry, I should have boxed this, 3 different formulas that we can use. So one of our formulas that we can write down is cosine squared theta minus sine squared theta. Okay, another formula that we can use is 1 minus 2 sine squared theta. And then the last formula that we can use is 2 cosine squared theta minus 1. Okay, and all 3 of these work for cosine of theta. And then lastly, for tangent of theta, we're just going to say 2 tangent of theta over, I'm just copying this down what we got over here, 1 minus tan squared theta. Okay? All right, so in number 1, it says simplify each of the following expressions and then evaluate. So right here, it says 2 sine of pi over 8 times the cosine of pi over 8. So when I take a look at this right here, I can see that theta is going to be pi over 8. And so essentially, this is just saying 2 sine theta cosine theta. And 2 sine theta cosine theta right here is just sine of 2 theta. So essentially, I'm just finding sine of 2 times pi over 8. Okay, but 2 times pi over 8 is simply pi over 4. So go back to our unit circle and look at where pi over 4 is. And if we look right here, our coordinate is at root 2 over 2, comma root 2 over 2, and sine is always y. So this answer here is simply root 2 over 2. Okay, all right, so now let's take a look at this next one right here. This says 2 tangent of pi over 6 over 1 minus tan squared of pi over 6. So here, our theta is going to be pi over 6. And if you notice, it says 2 tan theta over 1 minus tan squared theta. That's what this is saying. So this right here is simply just tan of 2 theta. But if we know that theta is pi over 6, then it's tan of 2 times pi over 6. And 2 times pi over 6 is pi over 3. So let's go ahead and use our unit circle to figure this out. So if I look at pi over 3 right here, pi over 3, the coordinate that we have here is 1/2 comma root 3 over 2. So remember, tangent of theta is always y over x. So if I want to find the tangent of pi over 3, I'm going to do the square root of 3 over 2 because that's my y value. Divide that by my x value, which is 1/2. Multiply by 2 over 2 to get these 2's to cancel out. So I end up just getting root 3. And root 3 is my answer for this question right here. Okay? Right. So taking a look at number 2, it says if cosine of theta is equal to -2/3 and theta is between 0 and 2 pi, so it's within 1 revolution of the unit circle, we need to determine the values of cosine of 2 theta and sine of 2 theta. Okay, so the first thing I'm going to do is I'm going to figure out what quadrants this triangle is allowed to sit in. So if I look right here, I know that cosine is going to be negative, which means that it's going to either be in quadrant 2 or quadrant 3. Okay, now the next thing I want to do is I'm just going to go straight to evaluating cosine of 2 theta, because the formula for cosine of 2 theta, there's one formula. You can choose any of the 3 formulas, but there's one of the formulas that's just in terms of cosine anyways. So if I already know what cosine is, I don't have to figure anything else out. So I'm going to use that formula. So if my formula says 2 cosine squared theta minus 1, then I'm going to go ahead and use that to figure this out. And I know that cosine of theta is negative 2/3. So I'm going to say it's 2 times negative 2/3 squared minus 1. Okay, so then right here, when I do this, I end up getting 2 times 4/9 minus 1. So this ends up being 8/9 minus 1. And 8/9 minus 1 is essentially 8/9 minus 9/9. So I end up getting negative 1/9. So that is my exact answer for cosine of 2 theta. Now, you could technically find theta if you want to and then go from there, but this is how we can get an exact answer quickly, okay? Now, to find sine of 2 theta, it's a little bit more complicated. So sine of 2 theta is going to be equal to 2 sine theta cosine theta. So this time we actually have to find out what sine of theta is. But again, we don't actually have to figure out what theta itself is, okay? So if we look right here, we know that our triangle is either going to be in quadrant 2, right here, or in quadrant 3, okay? But what I'm going to do is I'm just going to draw my triangle out right here. So, and I'm going to draw my theta so I have an idea of what's happening here. So this is theta right here. And if cosine of theta is negative 2/3, remember cosine is always going to be, when it's not the unit circle, it's x over r. So right here, my x value is negative 2, and my r value, my radius, is 3. So what I can do is I can figure out what y is by using the Pythagorean theorem. So I can say y squared plus negative 2 squared equals 3 squared. Okay, so then I would get y squared plus 4 equals 9. Solve for y. Subtract the 4, so that means y is equal to the square root of 5. So this right here is no longer unknown. I know that this is the square root of 5. But it's also possible for us to have our triangle down here. And if that's the case, then this y value is negative square root of 5. Okay, because everything else is staying the same. So in order to figure out what sine of 2 theta is going to be, all I need to do is identify what sine of theta is. So sine of theta is always going to be, so this is cosine. Sine of theta we know is always going to be y over r. Okay, so right here, when I take a look at this right here, the y value is square root of 5 or negative square root of 5, and the r value is 3. So sine of theta could be plus or minus root 5 over 3. Okay, so to figure out what sine of 2 theta is, I'm going to plug in my information. So I know it's going to be 2 times the sine of theta, which is plus or minus square root of 5 over 3, times the cosine of theta, which we already know is negative 2/3 right here. Okay, so I end up getting here, this 2 times this negative 2 is negative 4. And negative 4 times this plus or minus right here, we'll just change it to minus plus. But it's pretty much the same idea, right? So the positive becomes a negative, the negative becomes a positive. So this becomes 4 root 5 over 9. So in other words, sine of 2 theta could equal 4 root 5 over 9 or negative 4 root 5 over 9. Depending what quadrant you are in. Okay? All right, awesome. All right, so question number 4 is really tricky. So number 4 says determine the exact value of cosine of 5 pi over 8. Okay? So what we're going to do is we are going to use the double angle formula here, but we are going to write out cosine of 2 theta is equal to 2 cosine squared theta minus 1. Okay, and if you guys notice right here, what we know, or what we want to find, is cosine of theta. So this time theta is going to be 5 pi over 8. But if theta is 5 pi over 8, that means that 2 theta is 2 times 5 pi over 8. Or in other words, it's just 5 pi over 4. Okay, so right here we know that theta is 2 theta is 5 pi over 4. So I'm going to fill in that information in right here. So here I'm going to fill in cosine of pi over 5, or sorry, cosine of 5 pi over 4 is equal to 2 cosine squared of 5 pi over 8 minus 1. And my goal is to solve for this cosine of 5 pi over 8. So what I'm going to do is I'm going to isolate this cosine of 5 pi over 8. So I can add 1 to both sides and divide by 2 on both sides. So this ends up becoming cosine of 5 pi over 4 plus 1 all over 2 is equal to cosine squared of 5 pi over 8. Then I can square root both sides, and I can see right here that the cosine of 5 pi over 8, so I'm going to write this up here, the cosine of 5 pi over 8 is going to equal plus or minus the square root of cosine of 5 pi over 4 plus this 1 all over 2. Okay? So now we know what cosine of 5 pi over 4 is if we use the unit circle, because if we look at 5 pi over 4, we can see that it's going to go up to here, and we know that this as a coordinate is negative root 2 over 2, comma negative root 2 over 2. So now that we've looked at this, cosine is always x, so we know that this is going to be negative root 2 over 2. So we know that this is going to be equal to plus or minus the square root of negative root 2 over 2 plus 1 all over 2 right here. But I want to get rid of all of my fractions. So what I'm going to do right here is I'm going to multiply numerator and denominator right here by 2 over 2. Okay, so when I do that, I end up getting plus or minus the square root of, when I multiply this number by 2, the 2's cancel, so I get negative root 2. When I multiply 1 by 2, I get plus 2, and then 2 times 2 right here is 4. Last thing I can do is I can square root that denominator right here, so I end up getting plus or minus the square root of, this negative square root of 2 plus 2, okay, all over 2, okay. One last thing that we need to take into consideration is where 5 pi over 8 actually falls in the unit circle. So it's going to fall before we get to pi, but after we get to pi over 2. So it's going to fall in quadrant number 2 right here. So it's going to be a little bit closer to the y-axis. We know it's going to fall in quadrant number 2, and because it's cosine, cosine is negative in quadrant number 2, so we don't have to say plus or minus, it's just negative, and that's our exact answer. Okay? All right, last one we're going to look at is proving this identity right here. So sine of 2x over 1 plus cosine of 2x is equal to tangent of 2x. Okay? So right here, what I'm going to do is I'm going to rewrite sine of 2x, now that I know what it is, as 2 sine of x cosine of x. Okay? And we're going to prove this just like we proved our identities last year. Okay? All over, I'm going to copy this one down, and then I'm going to say plus. Right here, cosine of 2x, I have a lot of different choices that I can use. I can use cosine squared x minus sine squared x. I can use 1 minus 2 sine squared x. Or I could use 2 cosine squared x minus 1. It does not matter. But if I know that cosine of 2x is equal to 2 cosine squared x minus 1, I might find that useful, because then I'm going to see that this 1 and this minus 1 are going to cancel each other out. But in all honesty, it does not matter which one you use. It's just going to change how you manipulate your equation around a little bit, and that's okay. Any one of those 3 formulas you use will give us the right answer. So if I use this one right here, I'm replacing cosine of 2x, I'm going to change tangent of 2x into sine x over cosine of x. Okay, so right here my 1's cancel out, so I end up getting 2 sine x cosine x all over 2 cosine squared x, and that's going to equal sine x over cosine x. Okay, so now that I've done that, I'm going to cancel out my 2's right here, and I also will see that right here, one of these cosines will cancel out with this cosine. So I'm left over with sine of x over cosine of x is equal to sine of x over cosine of x, and I've proven my identity. Okay, that's it. Let me know if you have any questions, and I will see you next time we have class. All right, have a great day.